quiet. Okay, welcome. We are going to continue on with Chapter 2, Lesson 1 in the Aerospace Science Flight book. Overview, we're going to have 5 lessons in here. We started yesterday with the atmosphere. We're going to finish up with the effects of the weather on the aircraft. Page 113, you can see the actual vocabulary that we'll be tested on. We had a pre-test yesterday. Let me give a question that I know will be on the test. Cat McKinney, it's New York. Why does the wind blow? Why does the wind blow? No, you can't forget.
The wind blows because the unequal heatings
The unequal, all right, everybody say it together. The wind blows because of the unequal. Yay, okay, all right, fantastic. How much oxygen are you guys breathing right this second? That's kind of basic. Okay, page 115. This is very interesting in talking about the jet stream. Okay, the jet stream is very important. What is a jet stream and what section of the atmosphere is it in? What's a jet stream?
Is a strong current of air that generally sits atop the troposphere and flows from west to east.
So, when we talk about the unequal heating of the Earth's surface and the fact that the wind blows because of it, that is true. Where does the wind come? Where's the weather coming? We're here in Prescott, we're in Arizona, but where does the weather come from? East or west?
West.
So when a big storm hits California, it eventually comes here. Same thing when I grew up in South Carolina, I would see the weather hit Mississippi and Georgia and eventually get to South Carolina. Yes, sir?
One way I know we'll always get something is if it goes through San Diego, we'll always get something.
There you go. A lot of times. Depends on the exact weather conditions. But this jet stream, look at the picture there on the bottom of page 115. That is it. That is why we get wind coming from the west all the time. It's a river of air, and the speed of it can be as high as over 200 miles an hour. There's a story of World War II of American planes flying over the Himalayas. You fly with how high is the Himalayas?
29,200.
Yeah, over 20,000 feet. And they're up over 20,000 feet flying in a plane, and all of a sudden they run out of gas, and they never ran out of gas before. Why would that happen?
Because the air is higher, or there's
They're going into a headwind.
Ding, 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 ding. Good job. Yes, you're flying into a 200 mile an hour wind, and if you're flying at 300 miles an hour and you're flying into a 200 mile an hour wind, your time across the ground is only 100 miles an hour. Takes you 3 times as long. And you run out of gas. That's how they discovered the jet stream, believe it or not. Incredible. So yes, the jet stream is huge. There's lots of theories about it. You can see how it wiggles there around America with the polar jet stream. A lot of times that's what they say, that's when we get the cold weathers, when that polar jet stream dips across America. Things get cold. You're coming up to the winter right now, you'll see this. It's fascinating, very fascinating. So the jet stream is a big part. What part of the atmosphere is the jet stream in? Troposphere, yes, exactly. Stratosphere, we talked about that. It's a huge boundary that separates it. We actually have a good picture there of it. Let me blow that up. With the stratosphere being going up to 160,000 feet. And we mentioned yesterday when you fly on a plane from here to San Diego, well, not San Diego, you won't go that high. Across America, what's the highest you're ever in an airliner?
40,000.
45. That's a good. Rarely do they get in the 40s, but usually it's in the 30s. The airliners own the 20s and 30s, sort of like. So if you're in a fighter, like I did, and I go cross country, I'd fly up at 47. I'd fly up above all that stuff. And the different parts of the atmosphere actually protects the Earth. It makes us unique. It keeps the Earth warm and the space cold. And you can see that the higher you go, the different temperatures do change. The Earth is, you know what, the highest temperature on the Earth is 100, 120. But look here, above up 350 miles up, the temperature can get hot, as high as 3,000 degrees Fahrenheit. This insulation fabric of these successive layers of the atmosphere makes the Earth livable for us. Okay? Water. Here's a good question. When you look up and you see a cloud, it's a good question. When you see a cloud, what is happening? What makes a cloud? What makes a cloud? Moisture in the air, but you're breathing moisture right now. Why don't you have a cloud out of your mouth?
Because it hasn't condensed into a giant ball of water, basically.
That's called a raindrop, right? Ball of water, pink. I'm talking about the light fluffy clouds you see up there. What's going on up there? Yes, sir.
Water is condensing on particulate matter.
Okay, microscopic particulate matter. It's just sort of staying up there. What about a thunderstorm?
It's all the positive and negative charges in the...
Yeah, that's true. That's true. What I'm getting around to, which you do need to realize, is when you see clouds, that's an exchange of energy. It's an exchange of energy, especially culminating in a thunderstorm. And so when you have this rolls of water in the atmosphere, water can be gaseous, it can be liquid, okay? Sublimation, it goes straight from, we see that every winter, right? When it snows here in Prescott, the next day the snow is gone. Does everybody see tons of water running everywhere? No, it generally just immediately goes from snow to gas. That's called sublimation. That happens all the time in Prescott. I've never seen it as much as is Prescott. The role of atmosphere, let's see. Here's another good question. We talked about, matter of fact, we talked about that just the other day, that going out by our Gateway Mall, you see the earth cut, and you see, you don't aware of it, but there's many dinosaur species, fossils in the corner, the side of the earth, and I think it goes up to about 220 million years ago. Why are we looking at 220 million year dirt? Why?
To predict the weather soon.
But I mean, no, why is it here? Why isn't it 3 miles under our feet?
Because we dug earthquakes.
Huh? Earthquakes bring it up, right? But what exposes then what exposes?
Water.
Water. There you go, rolls of water. So therefore, you think about it, every time it rains, one grain of sand will leave. And you go, that's not a big deal, but millions of years, Granite Mountain. Anybody ever been up to Granite Mountain? Or anybody walking the Peavine Trail by the Dells? How old are those rocks?
Really old.
1.2 billion years old. And they're sitting up here on the top of the earth, and some of them are rounded, some of them are jagged. It's all because of rain and wind. It's all because of rain and wind over 1 billion years. It's amazing. So the rolls of water, the bottom line is the water just shapes the entire earth. Evaporation. If the earth is surrounded by 75% water and the oceans have all the evaporation, it does absolutely come back down to the earth as rain. Sublimation, we just talked about that happening all the time here. Comes straight from snow. Straight from snow to gas is sublimation. And humidity. This is something we never think about here. What's the humidity today in Prescott?
64.
I think it's 40% because it's been a front coming through. What's the average humidity? Yeah, like 10, 8 or 10. I know it's always 8. Seems like it's always 8%. East of the Mississippi, humidity is a lot higher. When I grew up, it was 80% generally every day. On hot summer days, it'd be 100% humidity and 100% degrees temperature. The bottom line is you have more humidity in the air the extremes of the temperatures feel worse. So 100% humidity and 100 degrees is a lot hotter than 100 degrees and 10% humidity. Okay? I'm just telling you, it feels a lot different when it's cold too. This morning, I think it was 27 degrees or something I saw, but you know, the humidity was not that hot, and I didn't even wear coat to school. Yes?
Yeah, like when I lived in California, we lived like right on the coast,
Right?
and it'd be like only like 80 degrees, and it would be blistering hot outside because it was like so
Humid. There you go. So you don't realize, so you cannot even compare when you talk to East Coast people and go, man, I can't believe Phoenix is 120 degrees. Well, you know what? That 120 degrees feels like 90 in Washington, D.C. It's not that bad. When I first moved out here, it was 100 degrees at 6 o'clock in the morning. I was running. It's no big deal. You wouldn't run at 100 degrees in the East Coast because humidity is so different. But there is something called a dew point. This is something you guys do not understand because this doesn't happen here very often. What is a dew point, guys? Page 119, top of it. What is a dew point? Yes, sir.
It's when the water, like, I remember when I was in South Dakota every morning, there'd always be like moisture in the grass and stuff, like all the condensation from
And what is that called?
dew.
Dew, and that is pretty rare here. There was dew on my car this morning, and it actually froze. That's pretty unusual. And I don't know exactly what the temperature, the dew point causes is when the moisture is saturating the air. But what you guys do not understand, because you don't ever see dew here, because it's so low humidity, is above 20 or 30% humidity, the dew comes out of the air as condensation in the morning, covers your grass, covers your automobile, window, and then, oh, by the way, if it's cold, 27 degrees like it was today, it freezes. What do you have to do when you have a car with a frozen window? You got to scrape it, and it stinks. But guess what? Every day, the majority of Americans in the winter do what? They shovel snow and they scrape their windshield because dew is everywhere in America other than the minority of America that is a desert, like Arizona, southern Arizona, some parts of California maybe, but it's very rare not to have dew every day of your life. Yes?
I actually know one trick to keep it from frosting over on your windshield.
How?
You take a towel and put it over your windshield before you
And then it freezes solid. You pull up the towel and it is a piece of metal like this. It's really hard. I've tried that. That's a great theory, but you obviously don't know about dew because it comes up and it's hard. And oh, by the way, the towel's wet. Does wet stick to wet? It freezes actually. And then you can't take the scraper and get the towel off. So it's pretty unusual that you guys do not know what dew is. But if you ever move out of Arizona, you'll find out. Particulate matter, this is what Cadet Heathington was talking about. Microscopic stuff, acts as a nucleus and starts a rain drop. Okay, here is something that you need to think about. Look at the big picture up there. When hot air rises, and in general, we talked about this at the beach, does hot air rise over the earth or over the water?
Earth.
Earth. The earth reflects the sun, heats up quicker, hot air rises. Matter of fact, one of my war stories, which I do have time to tell you, is I was flying, when I just learned how to fly when I was about 22, and I actually was flying over the Bahamas. And the Bahamas are a bunch of islands off the east coast of America, and I was going there with my friends. And guess what? I got lost. Because, has anybody ever heard of the Bermuda Triangle?
Yes.
It exists. Don't ask me now because I don't have time, but I'll tell you this, I'll tell you sometime. So I was flying over the Bermuda Triangle, and I looked at my compass, and it was spinning. It's a good thing to talk about on Halloween, right? I had a spinning compass, and I go, oh my gosh, I am lost over the Bermuda Triangle. I'm going to be on TV on the History Channel when I disappear. And so I just kept flying, and there was no navigation aids, and all of a sudden the clouds started coming down, all this stuff was bad. But how do I navigate? And of course, I had researched it, and I had learned about weather. If you're flying over the ocean, and if the air rises over land, where will the clouds be?
Over land.
Yes. And so I looked out on the horizon, I saw a cloud, and I go, I bet you there's an island over there. Boom, and there was an island. It saved me. So this knowledge right here that you're seeing up here saved my life when I was 22 years old. Of course, I got over land. I go every island there has an airport. and I figured out where I was, but that was a fun little thing. So yes, the hot air rises, and hot air rises. Oh, there was a question from let's review from yesterday. For every 1,000 feet, how much does the temperature decrease?
1.2 degrees.
Keep going.
2.5.
2.5. There you go. So if you have this hot air rising and it goes up 10,000 feet, okay, then it will decrease 25 degrees. And then it'll condense and it'll rain, right? That's exactly what will happen. All right, Coriolis effect. This is quite important. Page 121. You must know about the Coriolis effect. And let's see, how can I easily explain this? See over there on the right, it says they have the red dots. Those are showing that the air rises over the equator because it's hot. And then the air rises up and it sinks over the poles. Okay? But yet all this time with this air rising and sinking because of the unequal heating of the Earth's surface, the Earth itself is spinning. And because it spins, it says it right there, it deflects air to the right in the northern hemisphere and left in the southern hemisphere. And this Coriolis effect makes the high and low pressure systems of the Earth go in a predictable fashion. This is why, again, the jet stream goes in a certain way around the top. This is the Coriolis effect is why we get our weather from California. Where does the weather in California come from?
The other side of the world.
Hawaii, the Pacific, right? I mean, it always comes from the west in this area because of the Coriolis effect and because of the trade winds. So, on a test, if I were to ask you about the Coriolis effect, what would their answer be?
It always comes from the west.
All right, read it right there on top of page 121. The Coriolis effect.
Describes how Earth's rotation affects the motion of air.
That's a fact. The guy's name was Coriolis, and actually there on the top of 121, it's all interesting to see that the Coriolis effect, because right now we're moving, right? If you get up on a plane and you're flying over a moving object, that affects you. If you're walking over a moving object, imagine if you're turning a little ball and you have a little ant moving on there, it's going to affect them. So even when you're walking on the Earth is spinning, it is affecting you, just a lot less than the Earth and then the speed of the winds. Okay, types of clouds. You guys should know this, right? You've seen all this stuff before. Types of cloud, page 122, I believe. Yes. This is very basic. You should know this. What does the word stratus mean? Could I read?
It means something.
It does mean something. That's very intelligent, yes.
Yeah, thank you. For this.
Stratus.
Stratosphere.
Stratosphere is true. What does stratus mean?
The lowest.
Low.
Near Earth's surface.
Rain clouds.
Wait.
Let's see if you can find it. Page 22, 23. Tell me what a stratus is. Stratus are level clouds, okay? So look at those clouds there in that picture, right behind me, okay? First of all, how high do clouds go?
20,000 feet.
Nope, way above that.
Oh, 40,000.
40. 40 or 50 is the highest a big hurricane can go, okay? You have stratus clouds that are nearer the Earth's surface. You have middle clouds. These are, you see these a lot in Prescott. Matter of fact, these were on Sunday afternoon. They were beautiful clouds right outside of Prescott, up to about 20,000 feet, okay? And then, of course, you have high clouds. Have anybody ever seen these around Prescott? This is interesting. In other parts of the nation, when you have a front come through, it is full of water vapor, and you have these huge thunderstorms come through. A Prescott front doesn't have much water because it's all evaporated. So a huge Prescott front might be indicated by this. This is called angel's hair, is a nickname, or ice crystals, and these are called cirrus. They're high. So you'll see these a lot in Prescott when the weather changes or when it gets cold, and usually it precedes, it's before the weather changes by 24 hours, 24 to 48. So you'll see these on a Saturday and you go, oh, tomorrow's going to be windy and miserable. And guess what it is? This is very simple to see. Yes, sir?
I've also heard of them being called the feather clouds.
Exactly. They're a lot of fun. These are neat clouds, and you see them here more than most places. Cumulus, vertical development. You see these when we have the thunderstorms in the summer, right? The monsoons. Mushroom, that looks like a mushroom cloud. Though that's kind of exaggerated. But basically, these are the most dangerous. You do not want to go flying through cumulus or nimbus cloud. Bottom of page 123, cumulonimbus thunderstorms. Do you want to fly through cirrus clouds?
Yes.
No big deal. Do you want to fly through stratus clouds?
Yes.
Yes, no big deal. Okay, I mean, they may have some weather, but these are the ones that will kill you. They won't really kill you. They'll just make you scared to death. They can have hail. They can have downdrafts. They can have wind shears. Scary, scary stuff. Matter of fact, what is a wind shear?
Wind shear is like a sudden drastic shift in wind speed direction or
A sudden...
may take place in the horizontal or vertical plane.
Excellent idea. We do have time for this. Here is my story. How about a wind shear? Here's your plane coming into land.
Awesome.
Okay, it's pretty neat. I am quite the artist, I know. All right. When you're coming into land, that's a critical time of flight, which we talked about last time. You have your flaps down. You're near the stall region. You're getting ready to land. And he wants to land right here. And let's say he is going about 150 knots, miles per hour, knots. And that's what he's going to land in. And let's say there's a headwind of, 15 miles per hour, 15 knots. And he is trying to get in because he has to eat food tonight. He wants to live in his own house. He's got press-home-itis, which will kill you as a pilot. And let's say there is a big thunderstorm like you just saw over here off the end of the runway. Okay? And it's moving. It's moving in towards the runway. He goes, but you know what? Guys, I can get in. It's no big deal. And so it is building up, and the winds are blowing, and it starts to get very, very windy. All of a sudden, this wind in his nose goes from 15 to 45.
It's like 105.
Okay? So all of a sudden, he starts going slower, right? So then maybe he starts to have to put in more power, right? To be able to fly. If he's going slower, he has to put in more power. And this big, huge thunderstorm moves through. And on the other side of the thunderstorm, the wind shear, remember I told you clouds are an exchange of energy? The wind shear changes, and all of a sudden, instead of it having a headwind, it will shear, it will change. And he has a tailwind of 30 miles an hour, 30 knots. So it's a 75 knot change in the wind. And this happens in 2 minutes, real quick, because the wind changes. So if he's going fast,
You gotta slow down.
all of a sudden he has to slow down, but he needs 150 knots to fly. And all of a sudden he's got 30 knots from behind, and his wind goes down to 120 knots, and he crashes. This happened in New Orleans to a big, huge plane, killed a lot of people. And so the bottom, and this can happen 20 miles from the storm. So on this picture that we had here on the screen, when you see a picture like this, you don't come within 20 miles of this. That's a long way. That's a lot of diverting your aircraft. It is the most dangerous cloud you can have. And of course, in the military, we have lots of sayings, but unless you're in war, you're never supposed to go near these thunderstorms that look like that. Alrighty, that will be where we will stop it today here on the end of lesson 1. We'll finish this up and go through weather elements tomorrow.